would be like a log of something, this would be like log of something, or the integral of both. Okay? So in other words, can I separate them? Can I make two fractions out of it? And this is what really is the essence of the partial fractions, is that if you have a complicated fraction in which there are, products in denominator, then can we simplify it? The answer is yes, actually. How to simplify it? Simple. So you have this linear fraction, so what should be the denominator of it? A numerator of it. The numerator of it should be a constant. So let's call that constant A. I don't know this constant for now. Okay? And let's call this constant as constant B. The next thing would be to try to figure out this A and B. So if you have a linear polynomial, you're going to have a constant in the denominator, for sure. Okay, for sure. So what should I do? So I have 5x minus 4, 2x minus 1 times x plus 1. Simplify this fraction, calculate this fraction, so it's going to be 2x minus 1 times x plus 1, and you're going to get a times of x plus 1 plus b times of 2x minus 1. Okay? So this would be really the LCM of the both fractions. Then what you can do, so the both of the fractions have the same denominator. So if their denominators are same, then numerators should also be same actually. A times of x plus 1 plus b times of 2x minus 1. So if the fractions are equal, the denominators are same, then the numerators must be equal. And our task is to find what do you call the fraction actually. Okay? Find the fraction. So an easy way of finding the fraction is that try to write this expression in the terms of such expression actually. So this is like some constant multiplied by x minus c. So it's a linear expression. So can I write something like similar to this? The answer is you can do it actually. So you're going to get ax plus a plus 2bx minus b. So I can write this as a plus, so if I combine these two terms, a plus 2b multiplied by x plus a minus b, and this is equal to 5x minus 4 actually. Okay? 5x minus 4. I just wrote the both sides in a linear manner actually. Now I'm saying that these two polynomials are equal. So this is a linear polynomial and this is also a linear polynomial, and both are equal. Now both will be equal if the coefficients are equal actually. This is equal to this and this is equal to this. So if you compare the coefficient of x with the coefficient of x, so you're going to get a plus 2b equal to 5. And if you take a minus b equal to say negative 4, then you have an interesting situation. So what you can do actually is that now solve this system. Okay? Solve this system of equation actually. So when you're going to solve this system of equation, what you will get? For example, one thing that you can do is to subtract, say, the first equation from other, a plus 2b, and say I have a minus 2b negative 4. So let's subtract this. So if you're going to do the subtraction, this will be minus, this will be plus, and this will be plus actually. A will cancel out and you're going to get 3b equal to, what do you call, 5 plus 4, 9. So the b would be equal to 3. So you got the value of the b. And if you got the value of b, just substitute in one of the equations. So in other words, say in this b, if I substitute 3, and you get negative 4, so the a will be negative 4 plus 1. So So you're going to get negative 1. So we found the value of A and we found the value of B. So if we found the value of A and if we found the value of B, substitute them back here. So the value of A is negative 1 and value of B is, what do you call, 3. So your complicated expression has been converted into a very simple expression actually. So if you want to integrate this, integrate these expressions. And it's not difficult to integrate these two expressions actually. Okay? It is not difficult to integrate these two expressions. For example, what is the first integral? 1 over minus 1 over 2x minus 1. So what should be the integral of this quantity? The answer is you can convert it into, you can make a substitution. So let's make t equal to 2x minus 1, so that dt will be 2 dx. You can say there is no 2 there, so I can put a 2 and divide by 2. Not a big deal. Okay? So after this simplification, what will this become? This will become 1 over t, and this will become what? dt. And what is the integral of 1 over t? So it's going to be 1 over t log of t, and hence 1 over t and log of 2x minus 1. Okay? 2x minus 1. And hence you can also compute the other integral, which is 3 over x plus 1 dx. You can check actually by the same thing that this is going to be 3 log x plus 1. And once you have this, just substitute them here and that, you're going to get a result actually. So substitute the value of this integral and this integral, and you're going to get what do you call your required integral. So what is the key thing in this partial fraction? Make a substitution like, okay, a over 2x minus 1, b over 2x plus b over x plus 1. Then make such simplification, write equations in such a form, make a system of equation, always solve it, and you're going to get these constants. Put them back into the expression, you're going to get such kind of expression, and then integrate actually. So the crucial part is really making this simplification actually. Okay, that's what essentially you have to do. But there are some very important pros and cons of this method actually. Okay? There are some important pros and cons of it. Remarks. We saw in our previous question that the degree of above equation 2x squared plus x minus 1 is 2. So the degree of this above numerator is 1 and the denominator is 2 actually. This trick would always work if the degree of the numerator is smaller than the degree of denominator actually. Okay, denominator. This trick would always work. So you can have a, say, a quadratic equation in the numerator, then a cubic equation in the denominator actually. A quadratic expression in the denominator, then the cubic expression in the numerator. So if you have a quadratic expression in numerator, then you should have a cubic expression in denominator. Okay. So the first remark is that degree of numerator should be less than denominator. Okay. should be less than denominator. So this naturally raises a question. What if the degree of the numerator is not less than denominator? What if both have the same degree? Or the degree of the numerator is, what do you call, is bigger than the degree of denominator actually? What to do in that case actually? So if degree of, say, so you have two situations. If the degree of numerator is equal to degree of denominator, or degree of numerator is bigger than the degree of denominator, in both situations, okay, in both situations, simplify the fraction. Okay? Simplify the fraction by doing the long division. So that's what we have to do. Then simplify, okay, the fraction by long division actually. Simplify the fraction using the long division. So here is one example. So here is one example. Here is one example. For example, you have a fraction like this, 2x cubed minus 11x square minus 2x plus 2 divided by 2x square plus x minus 1. Okay? So the numerator is cubic and denominator is quadratic. So what should I do? Then you have to do what do you call long division and simplify this. Okay? Long division, simplify this. So if you are dividing, say, a number n by m, and same would be true for the polynomials as well. So if you have a number n and you are dividing it by m, so I can divide it. It's not a big deal. How can I divide it? So I'm gonna read the table of m. So there will be some quotient. Okay? There will be some quotient q. So I can multiply this m with q and I'm going to get what do you call mq. And then subtract what do you call n with mq and you're going to get some remainder actually. You're going to get some remainder. Then what you can do actually, so n minus mq is r. So if n minus mq is r, that means n is m multiplied by quotient plus remainder actually. So if you are multiplying n and dividing n by m, there will be some quotient and there will be some remainder. And you can write this as mq plus r. Okay? There will be some quotient and there will be some remainder. So for example, you can say that, okay, if I am dividing 5 by 2, then I know that, I can do this, 2, and this will be 4, and you're going to get 1. So maybe I do 3 actually. This would be better. So you're going to get 2 here. So this is the divisor, this is quotient, and this is remainder. Now 5 can be written as divisor multiplied by quotient plus remainder. Should be 3. Should be 3. Okay? Divisor multiplied by quotient plus remainder. So So that's what I'm saying. When you are dividing n by m, so n is going to be the divisor multiplied by quotient plus remainder. Okay, plus remainder. So you can write it in this manner. Now, so like this was the basic fact about numbers. The same is true about the polynomials. So when you have a polynomial, say for example, I don't know, p of x, it is divided by some, I don't know, maybe some s of x is divided by t of x, then there will be a quotient polynomial and there will be a remainder polynomial actually. And s of x will be t of x divisor multiplied by the quotient plus remainder. Okay, so this is just a quick review of the basic algebra. You have to know the basic stuff actually in order to do the partial fractions. Okay, so what to do now? So let's do the division. Let's put our 2x square plus x minus 1 here. Let's do 2x cubed minus 11x square minus 2x plus 2. Okay. So what should I do? So you can do one thing. Take the leading term in the polynomial and see what is the leading term in the divisor actually. So this is 2x cubed and this is 2x square. Now what should I do with the 2x square so that it becomes a 2x cubed? What should I do with this term so that it becomes this term actually? So I hope you remember the basic principles of division. Okay? So what you can do is that multiply it with x. So that means you have to put x here. And now if I multiply 2x square with x, this will become 2x cubed. If I multiply x with x, this will become x squared. And if I multiply minus 1 with x, this will become negative x. And then simplify. So when you're going to simplify, so you have to subtract. So these two terms will go away. 11x square minus x square is going to be 12x square. And minus 2x plus x is going to be negative minus x plus 2. Can we go more? The answer is yes actually. Yes, you can still go more actually. Because the both degrees are same. Okay, so this is a quadratic equation, this is a quadratic expression as well. So you can divide a quadratic expression with a quadratic expression. How to do it? So in other words, what should I multiply with 2x square so that it becomes minus 12x square or then negative 12x square? So you have a 2x square already. What should I multiply with this so that it becomes 2x square? So that must be negative 6. So let's put negative 6. So when you're going to put negative 6, what are you going to get? So this is going to be negative 12x square, and then x times negative 6 will become negative 6x, and this will become plus 7. Okay? So if you make subtraction, what would be the final answer that you get? The final answer that you're going to get, so these two terms will go away. So this will become 5x, and minus 2 minus 7 will also become minus 5x. So this is the remainder. This is your remainder. This is your, what do you call, quotient actually. Okay, this is your quotient. So what we can do now? So now you can make convert this expression. So thus now you can say that 2x cubed minus 11x square minus 2x plus 2 is divided by 2x square plus x minus 1 is equal to what? So it's going to be quotient, which is x minus 6 okay, plus remainder, which is 5x minus 5 divided by the divisor. So what is divisor? 2x square plus x minus 1. So in other words, you simplified this expression up to, what do you call this expression actually? Now when you're going to take this, multiply with x minus 6 and add 5x minus 5, you're going to get the same expression. Now what is the good thing with this expression? That the degree of the numerator is smaller than the degree of denominator actually. And once you have it, you know, now you can repeat the process that we did before and do the partial fraction of this expression actually. And once you are done with the partial fraction, if you want to integrate this, just integrate, what do you call this expression? Okay, what do you call this expression? So the first remark is that if the degree of the numerator is greater or equal to the degree of denominator, then do the long division and simplify it. Simplify it. Okay, so this is the basic level mathematics, 8th, 10th, O levels mathematics. Okay, so I hope you know this basic stuff. So that's the first remark that I must say. What should be the second remark? The second remark is, what if you have in denominator, okay, so it's like the degree of numerator is smaller than denominator, but the trouble is that in denominator there is a linear expression which has more than one multiplicity. For example, the second remark is, if your expression has more than two factors actually, like this, x multiplied by x minus 3 multiplied by 4x plus 5. Okay, it doesn't have two linear factors, but it has 3 linear factors. So what we're going to do? We're going to do same what we did previously. So a divided by first linear factor, b divided by second linear factor, and c divided by the third linear factor, 4x plus 5. And do the same what you did previously and try to find a, b, c. And once you have it, you know, do the integration of both sides. So what actually you are doing now is partial fraction. So partializing the fractions actually. Okay, this is what that you are doing. The third remark is, if the one factor is repeated actually. So imagine you have this kind of a situation. X plus 6, x plus 2 square times, what do you call, x minus 1. Okay, x plus 2 square by x minus 1. Now, so this is like x plus 2 multiplied by x plus 2. So what should I do then? So what we should do then in in such situation actually. So if you have such situation, okay, then what you can do? You can do this, so you have to do this. So a divided by the linear factor x plus 2, the first, plus b divided by the not linear factor, but x plus 2 square actually. Okay, so if you have a square, first you have to keep the linear factor, then its second power, plus c divided by x minus 1. C divided by x minus 1. So in other words, if there is x plus 2 square, a linear factor square, then that linear factor and its square power both will be written separately. Okay, both will be written separately. You're going to ask immediately a question. What if you have x plus 6 divided by, for example, x minus 2 cube and say x minus 1 square actually. So in which x minus 2 is repeated 3 times and x minus 1 is repeated 2 times actually. So what are we going to do in that situation? So in that situation, what you're going to do, you're going to do a divided by x minus 2. You have to put the all factors. So x minus 2 square and x minus 2 cube. So you have to put all 3 factors actually. And same is the case with this. So the d by x minus 1 and e by x minus 1 square. Okay? X minus 1 square. So in other words, if you have such kind of an expression, then it's, if you want to break the fractions, there will be a term with the x minus 2 in the denominator, there will be a term with the x minus 2 square with the denominator, there will be a term with x minus 2 cube in the denominator, and x minus 1 and x minus 1 square actually. So you have to put the all factors. Okay, x minus 2 square cube, so if there is even more power, you're going to put that power as well. Okay. So this is the third remark actually, that if in the denominator some linear expression is repeated, you have to, write the expression in this manner actually, and then try to find the constants. Okay, then try to find the constants. The final remark actually. What if you have up to, so whatever fractions that we have seen up to this time is that you have a linear fraction in the numerator, okay, and what do you call a higher degree polynomial in denominator. What if you have something like this? So x square plus 1, okay, divided by so imagine you have x plus 6 divided, for example, by, so what you have so far are just, what do you call, linear terms actually. How about now you have this? So you have a one term like x plus 1 and you have another term like x square plus 2x, or maybe x square plus 2. So the one factor is linear and another is quadratic actually. Or it could be higher degree than quadratic as well. So for example, let's just stick ourselves with quadratic. So one factor is linear, another is quadratic. So when you are trying to write this kind of partial fraction, what you have to do is that first in the numerator of the linear factor you have to put x plus a, a actually, so constant a. And in the numerator of say x square plus 2, you have to put a polynomial of 1 degree less actually. So this is a second degree polynomial, so you have to put an expression which is 1 degree less, which is like bx plus c, so a linear expression. Why you are putting a constant here? Because this is 1 degree polynomial. So what is the polynomial that has 0 degree? So the 0 degree polynomials are constant. So if the numerator is quadratic, so if the denominator is quadratic, the numerator must be linear. So if the denominator is cubic, okay, the numerator would be quadratic actually. Are you getting the point? So that's what really is the essence of it. And for example, if you have to simplify such kind of expressions, then This is what is really one way to do it. Let's do one example based on it. So this is